Hello everybody, my name is Jörg Vollrath and I want today present EEBench. It's a hardware-based oscilloscope and arbitrary waveform generator. So you see the hardware down here in the picture. You see a Basis 3 FPGA board which has on the left and right side PMODs. The board is around 120 to 180 euros, and I want to realize with this board an oscilloscope, 4 channels, and arbitrary waveform generator, which is depicted here. So on the right side, you see from the PMODs mod 16 lines going to an R2R DAC, generating a 16-bit analog signal, and then the signal goes back again to the 4 input XADC channels of the Artix FPGA and can be then displayed in oscilloscope-like fashion. So for this project, I did a VHDL coding for controlling the FPGA, and I did a nodeJS project with a web interface to operate everything. And I wanted to show you today this one. So let's start with to initialize the hardware by looking at programming the FPGA. So let's go to the Vivado design suite. So this is the Vivado project, which is in the zip file. So you see the main file EEBench. I already generated a bitstream down here. So if you loaded all the files in here, then you generate the bitstream. And to generate the bitstream, then I already did this. So next one, I open the hardware manager. I open the target so that I can program my FPGA board. So this happens now. Okay, so now I can program the device here, and I program the device, and now the hardware is configured, acting like an oscilloscope and a waveform generator. So since the serial interface is now busy, I have to close the Open Hardware Manager so that my web server then can connect to the hardware. So now let's look at the user interface for the hardware. So we have to look into the right directory. So here I see on my hard disk I have a folder node EEBench with some submodules for HTML with my main program down here under Projekte and EEBench. This is the HTML file which will display the user interface. But to start everything, I just click here on node EEBench, and then you see I have to show you what happens. First, what happens is a PowerShell window is opened here. So I start with node, the server EEBench.js. It looks at the COM22 port for my PC, and the COM22 port is configured in my nodeJS server file. And here in your browser, the HTML file is loaded and I see a user is connected. So next, let's go now back to the browser to look how the user interface looks like. Good. Here we are in the browser. We see, okay, we have a Basis 3 board with my XADC. We get 256-bit, and this is a configuration. Now let's look at the waveform. Here you see the arbitrary waveform generator running at 2 kilohertz with 400 millivolts amplitude, and let's put it here, 500 millivolt offset, so that we are not out of bounds of the input of the XADC, which has an input range from 0 to 1 volts. So we can run this one, and then we can go to the oscilloscope, and we see it's running here. You have the live waveform. You see it's moving. The trigger is on AVG1, is rising at 500 millivolts, is working. If I put it at 2 volts, it's out of bounds, so it's wandering the waveform. So let's put it back to a standing waveform. You can enable and disable waveforms. You can move them up and down. Yeah, you can move them right and left. What else can you do? You can change the time base. You see on the right side different values for the measurements, the minimum, the maximum, the average, the amplitude. You see the time, the period, and you see the frequency. And then what you can also see is another tab where you have the FFT, and you see here the FFT. And since I don't have any windowing and it's not fitting into the frequency, you see here the bleeding of the width. So we just take this one over, Control 4. So we see we have this kilohertz. We see, okay, this is my thing. And now if I look at the FFT, I see, yes, I get my signal to noise. The orange one is the ideal source synchronous. So here I see -10 and -35 dBs. And then on the real one, I see the actually values of the R to R DAC. Thank you for your attention. I wanted to show you this project. At the end, I can show you also a histogram with different number of curves. Here you see what kind of, how many measurements are with which value on the x-axis. I think the project is in a state where it's very useful for you. You can modify the VHDL code, you can modify the DAC, you can modify the ADC so that you can build your own oscilloscope and signal generator, and that you can also build your own user interface based on the HTML code and on the JavaScript code, which is all provided here as zip files down here, version 06. You see it's a very early version. Not all features are working. It's not working quite well, but at least it's working as I demonstrated it before. Thank you for your attention.